Hey guys, let's take a look at this problem in the 3-7 homework. We were in this problem looking at the product rule function of the exponential function 18t to the negative t over 3 power times the cosine of pi t over 6. Okay, so first thing it wanted to do, or wanted us to do, is just to graph the original function. So what I did in order to graph that original function was I just treated the t values as x values in order to easily enter them into the calculator. And I just said 18e to the negative x over 3 cosine of pi x over 6. And the MyLab makes it easy to know what the calculator window should be, because look at all four answer choices on MyLab. All of them had the x components 0 to 20 and the y components negative 18 to 18. So that's what I did, and I was easily able to see that it was graph A here. Now, the second part of this is what I'm interested in, taking the derivative of the function. So we know that the derivative of any displacement is velocity. So the velocity function is the first derivative of the displacement. Whenever I go in and find that, I had to remember it's a product rule. So that's what I'm trying to show here. It's the derivative of the first times the second plus the first times the derivative of the second. Okay, now in that derivative of the first term, it's a chain rule in and of itself. We can say the derivative of any exponential function is that exponential function times the derivative of its exponent. You'll notice that I rewrote the exponent instead of t or negative t over 3. I wrote that as the equivalent negative 1/3 t. That more easily allows me to see that the derivative of the inside part is just negative 1/3. So the derivative of that exponential function is 18e to the negative 1/3 t times the derivative of the exponent, negative 1/3. All of this is times the second plus the first, now times the derivative of the second. Derivative of cosine is negative sine. I keep the angle. And again, I rewrote the angle of pi t over 6. That's the same thing as the coefficient, pi over 6 times t to the first power. So it helped me to write the angle like that. And then now when I say the derivative of the inside, it's very easy to see, well, derivative of the inside is just pi over 6. Now, this is the correct derivative at this point. I just needed to simplify it down some. So in simplifying, what I did in the first term is I saw I had a 18 times a negative 1/3. That gave me negative 6 times that exponential function times the cosine of pi over 6 times t. In the second one, I'm going to have the 18 times a negative and a pi over 6 here. So I get negative 18 divided by 6 is negative 3. Multiply it by pi. So I had minus 3 pi times the exponential function times the sine of pi over 6 times t. Again, this is a correct answer for the velocity function in this problem. I wanted to go ahead and factor it, though. I don't know if that you necessarily had to. It looks like the answer that MyLab wanted was a factored answer, but I bet they would accept this non-factored answer. Now, I actually don't like the way that they factored this. When I'm factoring this expression, what I would do is I would say, look at the greatest common factor between the first term and the second term. They don't have a trig function in common, but what they do have in common here is the coefficients, the negative 6 and the negative 3 pi. I can say, well, I can pull out a common of negative 3 between those. And then, of course, the exponential function e to the negative 1/3 t is in common. So that's what I chose to pull out. When you pull that out, you'll be left with 2 cosine of the pi over 6 times t plus pi times the sine of pi over 6 times t. Now, if you pull out a negative 6 like they did, you'll have just the cosine for the first term, an understood coefficient of 1, and this term would be pi over 2, which that's okay. I like the way I've done it better, though. I'm sure my lab would count either correct. Now, the last one asks us to graph this velocity function. So what I did, again, just the same as the original, I replaced the x with t on my calculator, and I noticed all of their graphing windows had x values between 0 and 20 and the y values between -6 and 6. And I went ahead and showed a screenshot of the result that I got when I did it. You can see that it's an increasing function. It looks like until about, looks like it increases up to a value of 1, 2, 3, 4, 5. It looks like it has an x-intercept of 5. It looks like it has a maximum right around 6.5, and then it's going to start decreasing down to where it reaches a minimum at approximately 12. Then it looks like it gradually starts increasing velocity after that. Okay, but there's only one graph on the screen that matches that, and it would be easy to choose with this graph. All right, guys, the most important part of this problem is, are you confident and able to take the derivative in this step? And then, of course, calculating the derivative using your chain rule and product rule, and then simplifying it out. The graphing on the calculator, that's of lesser importance, but make sure you do understand the derivative process in this problem. All right, let me know if you have any other questions.